Hi, this is Mr. West, and today we're doing a Kuta worksheet tutorial on function transformations. I'm going to give you a quick overview. We're going to talk about graphing and how do we graph the parent functions. Then I'm going to talk about the different types of transformations and how we recognize them, and then we're going to do some problems, including some graphing. So if you can jump ahead to whatever section you want, and we're going to go ahead and get started. So with linear, the equation is y equals x. We can make a table and input values of x and get a corresponding value for y. We could just do something really simple like -1, 0, 1, 2, 3. And we can see what we're going to get for y when we plug in those values for x. So if you plug in -1, you're going to get -1 for y because y is equal to x. If I plug in 0 for x, what do I get for y? Well, y is equal to 0. See, y equals 0. So I get 0 for y. If I plug in 1 for x, y equals 1. Okay, so it's very simple. It's linear. This is the basic building block, and you're going to see that all these are going to be the same. So this is what it looks like. I'm actually just going to make a line, and it snaps into place, and it looks like that. I'm going to create my arrow. That's linear. Okay, so that's the basic process. You can use the table to find the line of what it looks like for any of these. For absolute value, pretty similar, okay? So if we're talking about positive values, it's very similar. We're going to plug in 0 for x, we're going to get 0 for y, 1, 1, 2, 2, dot, dot, dot. It continues. However, in the other direction, I'm actually going to erase this. In the other direction, if we plug in -1 for x, now it's going to be a little different with absolute value. So if we plug in -1, absolute value changes anything. So before we were putting in positive numbers, it stays positive, y equals 1. Absolute value takes anything that's negative and turns it positive. So y equals, absolute value of -1 is +1, so this is going to be +1. If we plug in -2, it's going to be +2. Let me just change this to -2, and then it changes to +2 once you take the absolute value. Same thing with -3 and so on. What does it look like when you're done graphing it? Let me get this out of the way. When you're done graphing it, you're going to have this relationship just like our linear line on the right side, but on the left side, it has to stay in the positive quadrant, so it goes in that direction right there. So that's what the absolute value is. A way to remember it, it looks like the V, just like the V for the value, okay? The V has that shape. The absolute value has that shape. So quadratic. What do we do with this one? Okay, same process. I just choose a couple different values for x, and we're going to see what we get for y. So -2, we're going to plug that in. So if we plug in -2, we're going to square it, and we're going to get that value for y. Y equals +4. So let me go -2, +4. I'm just finding that point. This is a coordinate point on our line. -1, if I square that, I'm going to get +1. 0, 0, 1 is going to be 1, 2 is going to be 4, okay? It's just the square value. So if I put -3, it's going to be 9. That's kind of off my chart. Just want to give you an indication. It looks like this. It's not linear, okay? It has a different pace. It's constantly growing faster and faster. This shape is called a parabola, okay? So this is something we're going to be coming back to. Okay, these are all the parent functions. We're going to be using these throughout this entire worksheet. Square root, a little bit more complicated. We have to come up with values that will work. One thing you'll know is you can't take like the square root of -16. There's nothing times itself twice that equals -16 because a negative times a negative equals a positive. So none of these values are going to be over here in the negative area, okay? But we're only going to have some positive x values. So I've put in 0, I'm going to get 0. I'm going to pick something nice and easy, 1, the square root of 1. Let me erase this. If I take the square root of 1, and that's going to be equal to y, y equals 1. So there's 1, 1. I'm not going to choose 2 because I don't know the square root of 2. It's like 1 point something, and we're not going to use that. But instead, I'm going to jump right to 4 because I know the square root of 4, and I know that's 2. And then I'm going to say 9, and I'm going to choose 3, okay? Square root of 9 is 3, 9, 3. So I'm going to plot these points. So you got 0, 0, 1, 1, 4, 2, and then 9, 3 is a little off the page, but it looks something like that. Okay, and that's my square root function. That's kind of like the weird guy. You need to know these basics and how to graph them in order to move on to transformations, which is next. So now we're moving on to transformations. What is a transformation? Well, transformation is a change in this graph. So translation is like a slide. So if we slide this graph around, Okay, let me grab my parabola here. Actually, I want to get the whole thing. So I get my parabola. If I slide him around just like this, that's a translation. So that's a translation. All right, and then what's the next one? Reflection. Reflection is just like it sounds. So if you have, for example, a reflection of the square root function, instead of like that, it's going to be flipped over the x-axis. If it's flipped over the x-axis, it's going to look like that. If it's flipped over the y, it looks like that. See, it's imagine like a mirror drawn, okay, over the axes, and it flips over them. That's a reflection, okay, depending on what axis it's on. And then the last one is vertical stretch and vertical compress. So briefly for that one, a vertical stretch, it gets skinny, and I'm going to talk about this again later. So imagine it gets skinny. That means it goes vertical faster. It stretches, like think about it, you pulling it like a rubber band. It gets vertical faster. A compress is the exact opposite. So it's going to kind of take its time stretching. It's going to take its time getting vertical. And it's what I would like to call, I mean, it's kind of dumb, but it's a simple way to remember. It's a little bit fat. So fat is compress. Stretch is skinny. And that's what those look like. Just you can rewind that or pause it if you want, but I'm going to talk about that again real quick over here. So translation, if we add k. So what is this talking about with this f of x? Don't get confused on that. It's just talking about one of our parent functions. F of x could be replaced by any of those parent functions. We could have y equals, it could be absolute value. And then when plus k, that just means like plus the number. So it could be plus 5. It could be y equals x squared, and then it could be let's see, we could do minus because we have that minus k. It could be minus 3. So we have different options, but the f of x essentially just means one of these parent functions. That's all it's talking about. So what does it mean if we add k? Just like add 5. That means we're going to slide it up. And if we subtract k, that's just the exact opposite. We're going to slide it down. Okay, so we're going to get into some examples later, but think about this real quick. If we're going to slide something up, okay, let's grab our parabola again. Okay, if we slide him up, we're just going to move him vertically. That's if we add k, and if we subtract k, then we move him down. Okay, that's that. Move him on to the next thing. If we subtract h, this is a little counterintuitive. With the subtract h, we're going to move it to the right, not to the left. And with the add h, we're going to move it to the left. So over here, back to this example, what does it mean when we're subtracting h instead of k this time? K I'm going to leave in green. I'm just going to bump him over. And you can actually have more than one transformation at the same time. Move these guys over. Okay. Hopefully that'll be enough room. So minus h would be something like minus 3 inside the absolute value instead of on the outside where that plus 5 is. And then if I have same thing with this quadratic function, I could have plus 1 in parentheses before I square it. And that's what it means by like having it inside the parentheses right here. So again, if I subtract h, like I did with this minus 3, okay, if I subtract h, that means, and we'll just use the square root function, if I subtract h, I move it over to the right. If I add h or add some number, I move it over to the left. So opposite of what we did with k, with the vertical. Reflection. So if we have a negative sign out in front, we are flipping over the x-axis. And if we're flipping, put the negative on the inside, that's over the y-axis. This is a good one to review with the square root. So if we have y equals negative square root of x, what happens is it's going to flip over like this. Okay, that's over the x-axis. See the x-axis? If we have that negative sign out in front of that square root function, that means it's going to get flipped over the x-axis. What happens when it's on the inside? Look at this. This is kind of cool. I love Notability. Great program. Okay, and then moving on the inside, what happens is this gets flipped over the y-axis. So then it's going to get flipped over like this. Like that. Okay, so that's if it's on the inside of the function. Okay, so let me go down here, right here. So the inside of the function, it's y-axis. X-axis is if the negative's on the outside. And like I said, vertical stretch, we already talked about that. This is if it's skinny. Okay, and it's if we multiply by a number out in front. So let's go back to our examples up here. If I multiply by like a 2, or let's say even a -3, notice how one's negative. The negative just means it's getting reflected in some capacity over the x-axis. But the 2 and the 3 are both bigger than 1. Okay, so we're looking at bigger than 1, but the absolute value. So just think 2, 3, 4, and their negative equivalents. It's when they get fat, we're talking about a fraction, okay, when it compresses, and we're talking about between 1 and 0 of a. So that, in this case, would be something like 1/2 or -1/3. Now we're talking about a vertical compression, and that, of course, again, is when it gets like this, okay, when it takes its time getting up. Now we're ready. This is the third phase of identifying like parent functions, what happens. So if we subtract on the inside like this, we already talked about that. This would be a shift to the right 12 units, or a slide to the right 12 units. And that's according to this over here. So if we look at this, we have a slide to the right 12 units according to our transformation cheat sheet. Okay, so that's the first one. Over here, if we have +7, okay, now it's on the inside again, +7. It's not on the outside, so it's not K. We're not going up and down. We're going to be going to the left this time. Remember, counterintuitive, and this is left 7 units. Now, 8, we don't have any addition or subtraction, but we have this negative sign out in front. That negative sign means we are going to be reflecting. Okay. Oh, I forgot something. It says identify the parent function. I'm so sorry. I forgot that component. So for number 6, our parent function was x squared. So our quadratic, y equals x squared. For our parent function over here, that was y equals absolute value of x. Okay. Now I'm with it. Parent function for number 8 is absolute value of x. What am I thinking? No, it's square root. I don't know why I thought so. Okay, y equals square root of x. Okay, and we're reflecting because we see that negative sign. Anytime you see negative, means we're going to reflect over, we're going to flip over the x-axis for this guy because it's out in front. It's not next to the x on the inside. Okay, number 9, we have a 2 out in front. This means we're going to do vertical stretch. Okay, it's bigger than 1, vertical stretch. And you could say of magnitude 2, but I'm just going to write vertical stretch. 11. We're going to have a negative on the inside. That means we're going to reflect. We see a negative. That means reflect immediately. I forgot parent function again. Absolute value of x. Parent function for this guy, number 11, is y equals square root of x. P stands for parent function. So I'm going to reflect over, this time I'll reflect over the x-axis because it's on the inside for number 11. 12, we have a fraction out in front. So parent function, I almost forgot this again, y equals x squared, and we are going to vertical compress. Vertical compress, and you could say by a factor of 3, I guess, or 1/3. We're multiplying by 1/3, but we're compressing just forget it. So we're vertical compressing. The value of a is 1/3. I just didn't want to confuse anybody. Okay, now we're graphing. Okay, so I'm going to kind of refer to these, okay, and I have my parent function drawn there. I'm going to show you how to do it without drawing it, or just taking something you've already drawn with the parent function. So we have y, we have a squared there, so our parent function is y equals x squared. That's good to know, and we see that it's -3, so we know we're going to start, instead of right here looking like this. That's a terrible parent function. I'm going to do it better, don't worry. I'm going to change to purple, actually, too. I'm going to start 3 units to the right. So I'm going to start 3 units to the right. That's right here. I forgot a point of interest. This vertex is kind of important. You want to know where that vertex is, where it kind of comes together before it goes in the other direction again. That's where we're going to kind of center this parabola. So y equals x squared is our parent function. And we want to have the same kind of relationship. So if we go over 1 unit, we're going to go up 1 unit to start on both sides. Okay, this is our parabola. And then we go over 2 units, we're going to go up 4 because we have that squared relationship because this is a parabola. So we're going to go over 2, 1, 2 to the left, and we're going to go up 4 units. Then we're going to go over 3, 1, 2, 3, and we go up 9. That's up here. Just to get the idea, over 3, up 9, just to get the idea. And it's going to look like this. Okay, and yeah, pretty good. Doesn't have to be perfect. But we get the idea that it's just a parabola that's slid over 3 units from the parent function. Next one I have highlighted, and I'm basically covering the highlighted ones because it covers every concept. If you do the highlighted ones, you understand how to do all the problems. So number 15, y equals x squared. This is our absolute value parent function, so y equals absolute value of x. Okay, and it's just slid over 2 units to the left. Again, with the absolute value, we have like a special spot. It's that kind of vertex thing, and that's where this is going to go. This time we're just going to slide it over, instead of from 0, 0, which is normally where it's centered, we're going to slide it over to the left 2 units, and it's over here on -2. Now, absolute value is a little easier to graph because it's like that stair step. Okay, we're going to go over 1, up 1, over 1, up 1, and then we're going to do that on both sides. Okay, whoops, I'm trying to, there we go, let me get it. Okay, so I want to split that at a nice 45-degree angle, over 1, over, up 1, over 1, up 1, and now I know I did it correctly. Okay, so that's like a quick graphing hack on a math hack on how to graph it quickly. Over here we have square root function. Again, the original one looks like this, okay, but we're reflecting over the x-axis in this case. So you can always make a table. I think this one is probably just easier to make a table for, and let me show you how that would work. I'm going to plug in 0 to start, and I'm going to get 0 for y. That's just what happens. Then I'm going to plug in 1. So if I plug in square root of 1 and then negative equals y, we're going to get square root of 1 is 1, but I still have that negative out in front, so now I have -1 for y. Then I plug in 4. The same thing happens for 4. Look, turn it to 4, but then becomes -2. Okay, so it's kind of like the same thing, 0, but just reflected. And this is a way I kind of ensure that I graph it pretty well. So 4, -2, and then 9 is going to be 3. It's kind of like our pattern that we had before, just underneath the x-axis this time. And then this one's the y-axis. So again, if I have my table, I have x, y, okay, and then obviously 0, 0. But then if I plug in, I can't plug in a positive. So because if I plug in a -4, we can't take the square root of a -4, so I'm going to have to plug in a negative number. So if I can plug in -1, because negative, that becomes square root of +1. So I can plug in -1 for x, and then it becomes 1. I can plug in -4 for x, and then it becomes 2, and so far. I think you see the pattern. So 0, -1, 1, -4, 2, okay, and you can see that it's just flipped over the y-axis this time, okay, because the negative's on the inside. Okay, we're almost done. So this time I have the minus on the outside. See how it's on the outside? This is our k. So I'm actually going to switch to green just so you can see that. This is our k. We're subtracting it. So I'm going to take my absolute value function. Okay, this is the parent function. I'm just going to graph him real quick just so you can see the point. And I'm just going to slide him down 5 units. 1, 2, 3, 4, 5. So if another way, if you don't want to do it that way, because you probably can't slide it with your pencil, just put the point there at -5 and then go up 1, over 1, both sides. Okay, that's how you would do it. All these are pretty similar. Okay, we have, most of these are slides left and right. This one is going to be a reflection, and then this one's another reflection. This one's a magnitude. So I already talked about this briefly. I think the best way to do this would be something like this. Make a table, so you're going to get 0, 0. You're going to want to go, you could probably just do it on one side and then just mirror it on both sides with the parabola. So if you plug in 1, you're actually going to get 2 now. When you get 2, you're actually going to get 8. So it goes up faster. Okay, and I'm just plugging these values in. I'm doing it quickly because I don't want this video to be too long. And then 2, 8. So it goes up even skinnier. Okay, just like that. So it's a skinnier parabola. And then this guy, same thing. I would just make your table x, y. You're going to plug in your values, 0, 0. I'm just do one side. 1 is going to be 1/4. I don't want to put 1/4 there. Okay, I don't want that. I'm going to show you that I'm just going to cross that off. And I'm going to put in something that I know is going to give me an integer. I'm going to plug in 2. Because if I do, I'm going to 2 squared. And then I have to multiply that by 1/4. I get 1/4 times 4. That gives me 1. Okay, and if I double it, if I put 4, that should give me, let's see, I get 16. 4 squared is 16. Getting a little messy here. Hold on. Y. Okay, so 4 squared over here. 1/4 times equals y. Y equals 16 over 4. That gives me 4. Okay, so now I'm kind of seeing a pattern here. So 1, 1, 4, 0, 0, 2, 1, 4, 4. Okay, so that can't be right. 2, 1. Hold on a second. So it's 16 divided by 4. That equals 4. Okay, so then, yeah, so it looks like this. That is right. Okay, so then I'm just going to mirror it on both sides. 2, 1, negative 2, 1. Oops, 0, 0, negative 2, 1. I need to move this over a little bit. Okay, this is taking a little bit longer than I wanted, but here we go. Negative 2, 1, negative 4, 4. Okay, so it's just got a nice, gentle rise to it. There we go. And last one, 30. So we can do compound transformations. That means more than one. This is our normal parabola. Okay, so this is like the 2, our 2, 4, 1, 1, 0, 0 guy. Okay, remember him? Not the wide one we just did. 2, 4, right? Negative 2, 4. Just want to make sure I hit that point. There we go. Okay, now what happens with this? I need two things. One, I'm going to move down minus 5. So I'm going to move him down 5. But then I also have to slide him to the left 2. So I move him to the left 2. 1, 2. And there I am. And that's how you would graph it. So that's all there is to it. I hope you enjoyed this video. Leave a comment if you need any of these questions done or an answer. I can probably answer in a comment. Or I can make another video on another concept if you need it. Either way, I look forward to seeing you next time right here on Wes Explains Best.